All right, I actually want to do this one with the class. All right, it was not very good on the homework. Again, it's a learning opportunity. You have to then switch your way of thinking and make sure you're thinking of this the right way now, okay? Tell me why this is not correct. And it's okay. You guys are still learning this. I had a lot of people doing this. They found the length of AD and the length of BC, and they're the same. And the length of AB and the length of DC, and they're the same. Awesome. What did you just show? Opposite sides are congruent. You just showed it's a parallelogram. Well, guess what? It said determine whether the parallelogram. Oh, it's already a parallelogram. That's wasted effort. Okay. And then I had some people find the slopes of AD and the slopes of BC. They're the same. Well, guess what? That makes it a parallelogram. Opposite sides are parallel. That's not what we're trying to show here. That is a great way to solve number. Nope, it was here. Show that this is a parallelogram. Number 8, show that it's a parallelogram. Great way to solve number 8. Show that the opposite sides are parallel. Perfect. Done. Not number 9. Okay? Number 9, you want to use the diagonals. So what happens if we find the length of AC and BD and they're the same? The diagonals are congruent. It's a rectangle. Okay? So we're checking for a rectangle. Is it a rectangle? Well, let's find the length from A to C. Distance formula. From A to C, I'm using A and C. Here we go. 2 minus negative 1 squared plus negative 3 minus 4 squared. 2 minus a negative 1 is 3, squared is 9. Negative 3 minus 4 is negative 7, squared is 49. AC is the square root of 58. Now, I could write that as a decimal, right? I could write that as a decimal, but I don't really care how long it is. All I care is it the same length as the other diagonal? So let's find the other diagonal. The other diagonal is called BD. B is here, D is here. 4 minus negative 3 squared plus negative 1 minus 2 squared. BD. 4 minus a negative 3 is 7, squared is 49. Negative 1 minus 2 is negative 3, squared is 9. Oh, look. They're both the square root of 58. Again, I don't care that it's, like 7 point whatever, 7.6 maybe? I don't know. I don't care what it is. They're both the square root of 58. So is it a rectangle? Yes. You're going to have lines on the quiz. Is it a rectangle? Maybe even circle yes or no. Yes. Then here's the next point you're going to get. Why or why not? Why is this a rectangle? Real simple. The diagonals are congruent. Diagonals are congruent. A great way to lose all the points is to graph it and just say it looks like a rectangle. Okay? You will not get any points. If you don't show this work, you're not getting any of the points, even if you circle a rectangle. I know it looks like a rectangle. You're not going to get any points without justification. Next, is it a rhombus? So that was the work for rectangle. Now the work for a rhombus. Do you remember how a rhombus inherited the 4 properties of the parallelogram? A rhombus inherited the 4 properties of the parallelogram. It has a couple new ones though. Its diagonals, they don't just bisect each other, they're also, the diagonals are perpendicular, and the diagonals bisect opposite angles. Good, right? Well, one of those is helpful here. If the diagonals are perpendicular, now I'll be honest, they don't look it. They don't look it, but you still have to show it, right? I'm expecting these diagonals to not be perpendicular. Those diagonals, the black lines, do not look perpendicular to each other. But don't go off of looks, go off of the math, the slopes. So we're finding the slope. Again, use the diagonals. The slope of AC and the slope of BD. The slope of AC, here we go. I go from A to C. I know it's going to be a negative because I'm going down and to the right. Down 1, 2, 3, 4, 5, 6, 7. Down 7, right 1, 2, 3. Down 7, right 3. Don't the slopes have to be opposite reciprocals? Guess what? I can look at BD right now and tell both of these black slopes are negative. They're both going down and to the right. Do you agree? I know they're not going to be perpendicular. You still have to show it. From B to D, I go down 1, 2, 3. Down 3. And right 1, 2, 3, 4, 5, 6, 7. Ooh, it's trying to trick us. Are they reciprocals of each other? Yes. What does reciprocal mean? You guys should know that word. They're switched. Are they opposite reciprocals? No. What does the word opposite mean? One's positive, one's negative. They're not opposites. Do you agree? But are they reciprocals? Yes. What's the reciprocal of 4/9? Positive 4/9, 9/4. Those are reciprocals. They're not opposite reciprocals. Negative 7/3, negative 3/7. Are they reciprocals? Yes. Are they opposite reciprocals? No. Do you understand that? Are these slopes perpendicular? Negative 7/3 and negative 3/7. No. Not a rhombus. Diagonals are, how are we going to word this one? Not opposite reciprocals. I would accept that. Not perpendicular, right? Not. And you can even use the perpendicular symbol if you don't want to write it out. Is it a square? No. It needed to be both rectangle and rhombus. Yeah, it's getting glitchy. Sorry about that. Rectangle and a rhombus. Does that make sense to you? Be honest. Does that make sense? Okay. What if you did the slopes? Different problem. Different problem. I'm changing it. Different problem. What if you did the slopes and one was negative 1/3 third, and the other one was positive 3 for the diagonals. Are those reciprocals? Yes. Are they opposite reciprocals? Yes. One whole fraction is negative, one whole fraction is positive. Tally.
Do you always measure slope from left to right? Because I always forget which
No.
way to do it and I get it wrong.
You don't, but you have to be careful if you don't. If I go right to left, here's what I would do. If I went from A to C, but instead I wanted to go from C to A, here's why you need to be careful. When I go left 1, 2, 3 to get under A, I went left 3. Where does the negative 3 go? Numerator or denominator? Rise over, run. I ran 3 left. Negative 3.
That's where I mess it up. Okay, thank you.
But go up. 1, 2, 3, 4, 5, 6, 7. Going up means positive. Question. I just said that's the slope of AC. Is that the same as negative 7 over 3? 3 over negative 7. Sorry, 7 over negative 3. Is it the same as negative 7 over positive 3?
Yes.
Yes. If any one part of your fraction is negative, the whole fraction is negative. If both parts of your fraction are negative, a negative over negative is a positive, right? So be careful there. All right. I would highly recommend going back to number 57 from the homework, redoing that one. It's in the back of the book. The answer's in the back. Okay? Make sure you do that one again. Most of you did not do it correctly, unfortunately. All right? What's wrong with using the sides? Mackenzie.
It just shows that's a parallelogram.
Thank you. Right? We already know it's a parallelogram. Save yourself some time. Don't waste your time doing that. Use the diagonals. All right? That's the easiest way to do it. All right. Number 8. Negative 9, 4. Negative 4, 8. 2, 6. Negative 3, 2. Negative 3, 2 is F. 2, 6 is E. And negative 4, 8 is D. All right, if we're showing that it's a parallelogram, show that the quadrilateral is a parallelogram. We want to show opposite sides parallel. Trust me. Show the opposite sides are parallel. That's the easiest way. Could you also show that the opposite sides are congruent? Would that make it a parallelogram? Yes, but that's 4 distance formulas. Would you rather count rise over run 4 times or distance formula 4 times? Rise over run, right? Rise over run. So let's show, we're going to do 4 slopes. We're going to do the slope of CD. And because I expect it to be the same as the slope of FE, I'm going to do that one next. And then I'm going to do the slope of the other 2 that should go together. The slope of DE and the slope of CF. Those are the pairs of slopes that should be the same. C to D, I go up 1, 2, 3, 4. I rise 4. I run 1, 2, 3, 4, 5. That, again, not the diagonal. We're doing the sides here. F to E, I rise 1, 2, 3, 4. I run 1, 2, 3, 4, 5. Rise 4, run 5. If that slope can reduce like 4/8 or 8/16 or whatever, reduce the slopes. All right, D to E. D to E, I have to fall 1, 2. I fall 2. And then I run 1, 2, 3, 4, 5, 6. Does negative 2/6 reduce into negative 1/3. Now from C to F, fall 1, 2, run 1, 2, 3, 4, 5, 6. Again, just to check your work, you should be able to look at these and tell whether they should be negative or positive slopes. Negative slopes go down and to the right, positive slopes go up and to the right. You should be able to tell which two sides should have a negative slope and a positive slope. It should just help you out, right? Does that make sense? Do you agree that's a lot easier than doing the distance 1 to the 4 times? Right? If you prefer to show the slope formula, y2 minus y1 over x2 minus x1, instead of counting, that's fine with me also. Have we had a chance to get to this proof yet? How many of you have attempted the proof yet so far? All right, just a handful. All right, everyone in the room, why don't you take a couple minutes and try that one. All right, if you've already done it, move on. The only problem is that angle is not the diagonal bisects opposite angles, right? But here's the problem. So it's probably the opposite. Let me try. All right, let's take a look at this one together. I know there's several routes you guys can take on this one. A couple are frustrating, and then a couple are a little bit easier. All right. So here's the number one thing you should do when you're looking at this proof. You should say, I see the rhombus they're talking about, and then I'm looking to see the sides they want me to prove are congruent. Does everybody see RQ and RS? If you're going to prove a pair of sides are congruent, 9 times out of 10, we've done CPCTC, right? So then you have to say, okay, before that, which two triangles do I want to prove congruent? Here is the tricky part. Here's the rough road, all right? Let's say you want to prove this triangle right here congruent to this triangle right here. Everybody see these two? Right? If I want to say diagonals bisect opposite angles, that's only true in a rhombus. That would be these two angles. Agree? So option A, the way I did it, you would prove these two, you would show these two angles are congruent. Reason? The diagonals bisect opposite angles. If you chose these two and you wanted to prove these two blue triangles are congruent, you'd have to use the linear pair theorem, and it gets messy. Okay? Do you see that? See the linear pair theorem? You could still do reflexive property. Yours would be RT, RT. And then you'd still have SAS, but it's just, it's messier. Now take a look at this other way. And a couple of you did it this way. If you choose these angles to be the angles that you are saying that the diagonals bisect in a rhombus, then you're looking at the big triangle here. And you're using PR as the reflexive side. And you have S, A, and then this S here. Now that's going to help you because QR, or RQ, is a side in that big triangle as well. Do you see how that path is a little bit easier? Yeah? And that just comes from experience and practice and saying, oh yeah, I could have done it that way. So before you start writing a bunch of stuff down, maybe plan it out and see which path might be a little easier for you. All right, I think I want to talk about this other one first. Number 7, is everybody okay with graphing 3 of the points and then using the slope to get that 4th point? Everybody okay with that one? All right. Tell me.
How would you write the answer for it?
For which one?
For 7, you would write the point where it's at.
Yeah,
I'm just say because of the slope of X and Z.
Yeah, you don't even have to give me a reason. I'm just going to put W. I'm going to put coordinates with a fill in the blank line. All you have to do is fill in the blank of what the coordinates are.
So you don't have to say why.
No, your work of showing the slopes might be helpful if you want partial credit if you get it wrong, but you don't have to explain why. Do you guys remember how to do this one where if it's called WXYZ, they have to go in that order as you're going around the parallelogram? Remember that? Okay, just be careful. There's a couple different parallelograms that could come out of it. Make sure you're doing the one that's named WXYZ. All right. We have 2 minutes left. I'm not going to rush through this proof. I will put this up and link it to the key tonight on Canvas. I do want to talk about these next couple. All right. What should you be careful with number 1? To solve for X first, you're going to have to, Jackson? Yeah, the consecutive angles add up to 180. And another one that comes up, there's not one there. What if you see a rhombus and you see diagonals and the angle's pointing to the angle where the diagonals meet? What angle is always formed when the diagonals meet in a rhombus? 90, right? They're perpendicular, 90-degree angle. Okay? So you should know the properties so that you can apply them in problems like that. The quiz is going to look very much like this one. All right? So practice problems like these. Come see me if you have questions. First summative grade of the 9 weeks, I believe, right? Have a great day.
What?